Friends, welcome to EPZ Pathsala. Today we are going to discuss technology and pedagogy. This presentation is part of your paper, Media and Globalization. In this lecture, we shall undertake a discussion on technology and pedagogy. First, the relationship between technology and didactics is established, followed by a discussion on pedagogical reasoning and how information communication technology is related to this, and finally, a brief summary on if at all, the media influence learning. Now, technology and pedagogy or didactics. Insofar as technology and pedagogy is concerned, the theory of didactics may provide the necessary fillip to an educational theory of technology, and this may be related to theory of education technology. Didactics, and for that matter pedagogy, is explained as the art of teaching, which is an European view, and also the art of instruction, which is an American view. Since technology is interpreted as application of science in ways of doing things, teaching is described as the art or technique of doing educational transaction. Technology brings in operational principles applied to teaching, and didactics would mean use of tools in teaching. The application of science or operational principles refer to structuring of the subject matter to be taught. Didactics subsequently got subsumed to the concept of pedagogy. Though earlier technology was associated with mechanical engineering, the development of the concept of philosophy of technology expanded the scope beyond what is called mechanical. Technology, distinguished from science, involves use of practical intelligence. It's a form of knowledge rather than application of knowledge. It's a form of knowledge, a frame of reference for doing things. Didactics involves reflection and evaluation in undertaking actions, and therefore didactical technology involves reflection on actions that technology is to cater to. The levels of technology include knowledge, artifacts, activity, and volition. Didactics as part of teaching employs any or all of these four levels of technology. In the Nordic countries, for instance, subsequently, a distinction was made between didactics and methodics, and methodics was subsumed within didactics. Extending the discussion further, we can also note that this distinction between didactics and pedagogy further. Didactics was described as the reflection on practice, teacher undertaking reflection on what one does to achieve effective student learning, and is necessarily a reflective practitioner. Pedagogy refers to the application of educational theory to teaching and learning, that is, unifying education and reflection of practice. When educational technology got further developed in forms of program learning, which heavily dependent on the behavioristic psychology and positivist research traditions, it led to association of the term technology to didactics. However, subsequently, educational technology movement could not get prominence due to the critical theory discourse by Jürgen Habermas, which critiqued the positivism itself. A distinction between educational technology and instructional technology was made. Educational technology was defined at the macro level, which renamed didactics as cybernetics, and instructional technology operated at the micro level in the classroom instruction. The cybernetic view of supervision and control of human behavior was severely criticized, and even the state system was castigated as technocratic, where the bureaucracy and the elites wanted to control and influence the citizens. Instruction technology came in direct conflict with didactics, and technology was criticized for its reliance on mechanization. Subsequently, distinction was made between didactics and methods. In methods, there was a technology dimension. The American stress on instructional technology was criticized since their stress was on educational problems, whereas, for instance, the German tradition, this stress is on educational issues. The humanistic philosophers started dominating over positivism, cybernetics, and so on, and therefore within didactics. This led to further developments within teaching methods of what is called problem-based learning, experiential learning, and project-based learning. These were very highly influenced by the works of the psychologists Jean Piaget and Vygotsky. The idea of dialogue pedagogy and structuralism got prominence. Didactics therefore subsumed methods again, though the instructional technology movement continued to flourish even today. That was the time when there were developments in educational media and technology, which included computers. The work of Habermas brought into focus technological determinism by some scholars. The educational technology movement got into emergence of what is called constructivism, which stressed that anything scientific and technical undermines theory and technology, and there cannot be single solution to any encounter. The final choice rests on the social actors from among options, and any problem is not static. It may change during the process of working for its solution, and this is very important. This therefore suggests that a shift to constructivism within didactics and decision on what and how to teach are also determined by many sociopolitical, ethical, and contextual issues. In the process of project method, the stress was started being given to self-regulated learning and intrinsic rather than extrinsic motivation. While didactics in the narrow sense focused on learning efficiency, in the broader sense it was proposed to consider to take into account the learning goals, the purpose of education, the specific learner group, and therefore would vary across contexts. So this would depend on context. There was a rejection of the positivist psychology, and a new sociology of education was initiated, which suggested knowledge to be personal, collegial, social, contextual, or theoretical, practical. Reflection on practice came into focus, which can be added to knowledge of pedagogy. You would recall Professor Donald Son's work on reflection in action and reflection on education, which contributed to this. The teacher was considered as action researcher and reflective practitioner. Didactics was expanded to cover practical reflection, political reflection, philosophical reflection, and finally, ethical reflection. The work of John Dewey led to further refinement in understanding of technology. He underlined that every reflective experience is technological inasmuch as it leads to newer meanings, and technology involves systematic inquiry to refine the productive skills. A reflective practitioner, therefore, is the one who has mastery of new tools and methods, plus advanced inquiries and ability to infer. What Dewey proposed was that testing and improving actions and tools, that is, improvement in technology, is possible through a critical and democratic process of inquiry, experience, and reflection. Didactics as educational theory of technology or theory of the art of teaching has derivations from Dewey's politicizing of technology and emergence of the practice of social constructivism. What is intriguing is what ICT is to do in this process of new pedagogy, that is, social constructivism. So let us talk a bit about ICT and learning. As we have seen in the discussion, the developments in media and technology have also contributed to reformulation of the relationship between pedagogy and learning. Pedagogy was discussed as part of educational practice, and the socio-political shift from behaviorism to constructivism has also induced information and communication technology to address constructivist learning. Further, the ICT-related pedagogies are related to the beliefs, values, and attitude of the users, in this case, the teachers and the students. One most important framework within which pedagogy and technology are dealt vis-a-vis subject content is technological pedagogical content knowledge, what is called TPAC, given by Misra and Queller. These two American educationists argued that since teachers do have content knowledge of their subject, they need to have further pedagogic knowledge as well as technology knowledge so that they can design teaching learning strategies such that they could put up in the lesson plan or the unit design which content will need which type of pedagogy through which type of media and which media combinations. The major focus of TPAC, as you see on your screen, is the teacher knowledge and its adequacy and appropriacy to teach effectively with technology. Reasoning, as we shall see in the next pedagogic reasoning, reasoning about a host of variables related to technology learning vis-a-vis technology is required from a teacher. Teaching is becoming more a complex activity with technology. What TPACS provides for is that it structurally unifies the complex activity with multivariables, and also it guides teachers to effectively to effect technology integration. What Misra and Kohler did was that they extended Schulman's PEC, pedagogic content knowledge, or the knowledge of interaction between content and pedagogy. About technological knowledge. Technological knowledge refers to teachers' ability to understand specific technology characteristics that can address specific learning styles of students and therefore facilitate design and presentation of specific learning activities. This also involves learning about the nuances of newer technologies. Pedagogic knowledge. Teachers are required to know which pedagogic principles or tools to bring into teaching learning, as also to manage and organize their teaching and learning. The entire gamut of teaching learning, starting from curriculum and course design to student learning assessment, including appropriate use of information communication technology, is included in this knowledge. Content knowledge. Teachers need to have full understanding of the structure and logic of particular content or subject or concept at specific levels like primary, secondary, higher education, as also across various discipline areas. This includes pedagogy related to content, not knowing the two separately, and appropriate methods of teaching, and specific technology related to specific content. Now, a few words about technological pedagogical knowledge. Technology needs to be used by teachers in specific context of content to design learning experiences with specific pedagogies can address. Therefore, teachers are required to have knowledge and skills to appreciate and use specific technologies for specific pedagogies and methods of teaching. And finally, TPAC, the technological pedagogical content knowledge. Based on all the categories of knowledge and skills by a teacher that we have discussed so far, the teachers are ultimately having a TPAC, the technological pedagogical content knowledge, where they have full understanding of designing technological inputs in the course design and lesson planning to address the pedagogic requirements of specific content areas, which can be at the conceptual level, practical level, collaborative level, or individually reflective level, or even group reflective level. Further understanding on cognition, metacognition, and self-regulation has better informed the conceptualization of pedagogy, both generic as well as discipline-specific pedagogy. L. Suleman presented a pedagogic reasoning model which is widely used, in which the process of teaching and transformation of knowledge are analyzed to facilitate the act of teaching. Knowledge may be generic or knowledge may be subject specific, and this can be about curriculum, about pedagogy and learners, and that there will be differences in pedagogic practices across subject domains. The framework talks of reasoning rather than thinking and focuses on teachers planning, teaching and evaluating rather than students thinking and reasoning. This is a continuous process in the teaching trajectory. So, when ICT comes into picture, the process gets both complex as well as facilitative. In the process, three variables are involved. One is teachers, two the students, and three the teaching learning vis-a-vis ICT. Let's look at this through a simple diagram. As you see in the diagram, ICT and pedagogic practices in the teaching learning process, three variables, teachers, students, and affordances, that is, the actual learning environment in context, including ICT affordances, are involved. Before drawing up any lesson or unit plan, the teachers bring in their knowledge, beliefs and values which influence their pedagogic reasoning. These are further reflected in the teaching lesson plan as well as in the teacher's classroom and otherwise teaching behavior. On the other hand, the students bring in their knowledge, including their prior learning experiences, their own beliefs and values to the contextualized learning environment. Besides the pedagogic beliefs of teachers, the affordances, that is, including the ICT affordances, determine the learning activities to be carried out by the students. Finally, all these lead to students' learning outcomes in terms of their knowledge, understanding, attitude and skills. The learning environment also includes what capabilities in learning have to engage effectively and productively in the learning environment. Insofar as ICT is concerned, the teacher's technology knowledge and the potential of particular or combination of ICT coupled with the pedagogy of ICT would obviously determine the effectiveness in student learning, the student engagement, and finally their meaningful learning. Decisions are to be made by the teachers that given the learning environment and available resources, what types of pedagogic approaches and resources can best engage students in particular activities and brings transformations in their learning. Technology or ICT affordances at both macro level as well as micro level, including particular software, open source and so on, they need to be very carefully identified so that students can focus on specific concepts and skills determined by the learning objectives. All these need to be translated into student activities, which should be, as far as possible, contextual and practical. And so, therefore, transfer of learning could be possible. Now, let us discuss a little bit about the influence of media on learning. Given that there is tremendous technology developments and there is massive deployment of media and technology in educational institutions today, a fundamental question has been debated for quite some time. That is, do media influence learning? The much talked about and published debate is Robert Clark, Robert Kozma debate. Robert Clark argued that media is just a vehicle. As a vehicle, carrying groceries has no effect on the nutrition of the consumers, so also media carrying instructional methods has no effect on learning. This is as much a situation within the classroom as outside the classroom, like for instance, distance and online learning. In distance learning, media plays a prominent role in the planning, design, development, delivery and evaluation of courses and of student learning. Robert Clark in 1982 contended that media carry the content, but has and will not have any influence on student learning. Media facilitates speed and brings an economy of scale by reducing the unit cost per student. Media research has so far ignored comparison between dissimilar media and that instructional methodologies have not been separated out from delivery technologies to see an effect. While instructional design or technology may have some effect, but delivery technology certainly not. Clark brought in the issue of replication, that if different sets of media and media combinations bring in almost similar learning gains in students, then certainly media has no role in student learning. Therefore, there is no significant difference in student learning due to the treatment of media as also due to replacement of one set of media by another set of media. In other words, any teaching method can be delivered through any media and bring in similar student learning outcomes. Therefore, Clark cautioned that there must be a distinction between methods and media, and the two cannot be either interchanged or equated. There are arguments against Clark's position that many media studies focused on the efficiency and effectiveness of relating to speed, time, cost, accessibility, and many other variables rather than on learning influence. In 1991, for instance, Robert Kozma contended that human learning is a complex process of cognitive, affective, social, and environmental factors, and that methods and media both are interrelated to each other in this process. He invited educators and researchers to further work on the relationship, since many studies had been inconclusive in their results. You would recall as early as 1977, Wilbur Schramm had underlined that it's not the type of the medium rather than the methodology and content provided through that medium which would contribute to student learning. Extending this notion, Kozma put forward that combination of a variety of methods, technologies, media, and learner preparedness contribute learning to occur. Therefore, future researchers should focus on the question that how can one harness the media attributes and capabilities to influence contextual tasks, activities, student groups, and therefore their learning. But let's get into another edge against both Kozma and Clark. David Jonasson and colleagues in 1994 objected Clark's view that only methods contributed to learning, and also Kozma's view that media as a carrier be placed in context to effect learning. Given that there are developments within cognitivism and especially constructivism, it is necessary to focus on human attributes in the context of mediated learning, which converges teachers, students, the context of learning, the social context, and instructional design, rather than on media and instruction per se. One must consider the contribution of or with media rather than presentation via media. Learning takes place in a context, and methods and media are part of this context rather than influence from outside. At the broader level, it is the learning environment which contributes to knowledge construction through experiencing learning in context. At the actual instruction and learning level, the design attention therefore must be given to the process of human information processing system. Cognitive resources depend on the tools of media, and therefore care must be given to proper selection of media and pedagogic methods to achieve higher effectiveness in learning. One must work further on media attributes which facilitate cognitive learning activities, which in turn affect thinking and therefore finally learning. We have come to the conclusion of this program. Let me now sum up what we have discussed in this lecture. We discussed the relationship between technology and pedagogy or didactics. The contribution of ICT to pedagogy and their relationship was also examined. And finally, we discussed, if at all, media affect learning. we came to a conclusion that in spite of debates for and against, one must consider the learning contexts in cognitive and constructivist learning pathways and the cognitive processing in individuals, and how best media can joint to facilitate this learning through experiencing. This brings us to the end of the lecture. I hope you enjoyed it. You are advised to read the modules carefully and attempt the questions given at the end. For an in-depth study, you can also refer to the Learn More quadrant, where we have provided resources. Thank you very much.